Another important component of the lifecycle management are the capabilities to do any of the disaster recovery, business continuity, and high availability. These three terms are sometimes used interchangeable, but here's what the most common definition of disaster recovery, business continuity, and high availability includes. First of all, disaster recovery is a system that allows one to recover from a major disaster, such as a flood, a weather, or a fire, where they typically come from the outside. And the recovery might be an up-to-date backup. If you have a fire that, for example, that takes down the whole hospital, or a hurricane that ruins everything, there needs to be the capability to have a backup, potentially on tape or another device, or on standby backup. But anyway, that within a short notice, the information can be recovered. Now, short notice that does not necessarily have to be within a minute or even within hours, but it might typically actually take a couple of days, but the information would be able to get to recover it. So that's the disaster recovery. Business continuity is typically when a local hardware failure or localized fire, or when somebody cuts a network cable, the capability to continue to do business. For example, if the radiology information system is down, one needs to have the capability to continue to doing business and schedule, let's say, temporary, using temporary numbers. So you still can take an X-ray, in particular if there's some critical information to be gathered. Now, the implementation of this could be done by a hot spare. Sometimes there's an automatic switch over, or sometimes a cold spare. That means they have to be started up. And it could be either on-site or off-site. High availability will be solutions that would deal with smaller scale problems, localized hardware issues, and network problems. And those are typically implemented by having a mirrored system. There could be a copy of the data stored on another device, and then if there's a problem from one, then the high availability solution would sometimes, maybe at the most, a little bit of a less performance, but automatically you will get access to that information. One of the solutions that is used a lot is what we call a test server. And a test server is like a duplicate system, but much less capability, or much less capacity. For example, it might be a server that can store all the images for a week. Now, this is a very good method to be used when you have a major upgrade. Let's assume an upgrade has to be taken place over the weekend, and it might take 2 days of downtime for the major upgrade to be installed on your system. On Friday night, the system might switch over to the test system. The test system might be preloaded with all of the data from the past week, so that there are any priors available. And then one can continue to operate through the weekend when there's a relatively low volume. And on Monday morning, and everything works okay, the information that was collected at the test system can be stored back at the main system, and you're ready to go. The test server can also be very useful for high availability cases. If the main system goes down, the test server could run for a couple of hours, even maybe, or for a day or so, with full capacity, and provide the services of the information system. Now, one can use a test server that is provided by the vendor, or one can actually build one themselves. There will be like a mini pack system that could be used as a backup. This table shows the different configurations for the core and what kind of capabilities you get. What is it that you get on business continuity, high availability, and disaster recovery? Now, most systems use RAID technology. RAID technology allows a single disk to fail because there is redundancy stored in the archive itself or in the server itself, that allows for automatic recovery of the data. However, the RAID is relatively reliable, but not if you have multiple disks that are that fail within what we call logical unit. So a RAID-only solution does not provide any business continuity, high availability, and a disaster recovery. However, if you have a RAID with a test server, the second configuration, at least you have a business continuity. If one of the systems go down, you can switch over to the test server. However, there's no data recovery unless you have a backup solution. So number 4, a RAID with test server, backup solution, and a local mirror is probably the most used and the most reliable and configuration, because the RAID provides your small, guarantee that small errors can be taken care of. The test server allows your backup, your high availability, your local mirror, business continuity, and then also you have a backup that allows you, in case of a major disaster, to be able to get back online within a certain reasonable time. And then solution 5 and 6, if you have a remote mirror or multiple copies, only provide extra guarantee. Most systems have either a 4 or 5 or even a 6 solution. The next important requirement is that the DHE manages images and related information. Now, with regard to the images, they are typically stored in a DICOM format. Now, it's not only images, but it could be structured reports, SRs, presentation state, PRs, or key object notes, key ONs. The non-DICOM objects, such as PDF documents, XMLs, other text-based formats, and TIFFs also have to be managed, including CDA and CCD documents that are defined by HL 7. These images and related information need to be able to be queried and stored and archived. In many cases, the attributes themselves have to be cleaned. For example, when a patient information is part of the meta file of an object that is supposed to be stored in a DHE, the image manager or the DHE might actually decide that we want to convert the name to all caps, so there's no confusion and no mismatch later on. Another requirement will be to limit the open queries, as we discussed before. If somebody asks for Mr. Smith, use a wide open query, that not the whole database will be dumped on the user, but only a certain subset. And part of the query, story, and retrieve mechanism will be to provide rule-based prefetching and routing. For example, when the image hits or when the data object hits the core, there might be a rule that images are automatically forwarded after 12 o'clock to a teleradiology site or to a doctor's home, for example. Or with regard to prefetching, when a new patient comes in, that automatically any of the information will be retrieved. The near-term storage, so that they will be readily available in case a physician would query for them. Open standards are a critical requirement for the DHE, and these standards include the DICOM standard and also standard access to database, such as using SQL queries, of course the HL7 standard and queries, and importantly the cross-document sharing and for imaging and for documents XDS and XDSI. Internal storage is well defined in part 10 of the DICOM standard that tells how to encapsulate the DICOM objects. The DICOM object could be encapsulated with a new metafile, with another metafile information that is standardized, so in case anytime the information has to be migrated, this is well understood by the receiver of the system. An important requirement is also the patient privacy and security. Patient privacy and security requires audit trails to be in a standard format as defined by integrating the healthcare enterprise. The standard that is recommended by IHE in their profile definition is ADNA. ADNA is a standard that means that one could actually have a centralized audit trail repository, and everybody could send that information to that repository, and at a central location a technologist or a system administrator can get the data for all the information. We need to have, of course, authorization and authentication, and these requirements are actually needed, the patient privacy and security, to meet meaningful use for implementing electronic health records for the United States. Another critical requirement is to be able to serve multiple departments and regional enterprises. Now that means that there needs to be access or a connection to an MPI provider and the PICS-PDQ messaging. So we need to have patient identification and patient data queries that are to be done from and to the enterprise, so we can resolve any multiple patient identifiers. As mentioned before, it is critical to have a patient-centric approach, so not study or department-centric, and in addition we need to have an interface to a personal health record or PHR. That allows information from the personal health record to be exchanged with the enterprise system. The other way around as well, the enterprise system could upload information to the patient personal healthcare system. Requirement also needs to be that we transcend upgrades and changes. We can swap packs and other department systems, and we can have an interchangeable migration, conversion, or data changes. So that might actually require some middleware to make a PACS or other departmental system open. There might be some conversion to some of the proprietary data into an open data standard format. Now you might ask yourself, okay, imagine I have a vendor-neutral archive. Am I all set? Well, the problem is that many vendors have different requirements and different definitions of what a vendor-neutral archive is all about. So I propose actually different levels of vendor-neutral archiving, level 1 to 5. The first level will be a simple DICOM archive, but only serves a single department. So I actually would argue that if a vendor says, well, we convert everything to DICOM and we have a vendor-neutral archive, that's not necessarily the case, because the level 2, right, we need also have to be able to serve multiple departments. We need to be able to have other data that it can be stored, such as EKGs and JPEGs. Now level 3 could actually also include multimedia, such as MPEGs and PDFs and Word. And at level 4, we actually transcend to the enterprise solutions. That means we have an interface that provides MPI master patient indexes. But in my opinion, a true vendor-neutral archive, level 5, would also have XDX PICS-PDQ interfaces, so you can resolve information that is provided from different patients across multiple enterprises. So in conclusion, the digital healthcare enterprise is a very complex system. We looked at it top down and we found many different components. And as a matter of fact, the typical hospital has hundreds, typically in excess to 100 different systems, different departments, different specialties, input system, output systems. Most of them have from different vendors, and they all need to be able to interoperate. The core of the digital healthcare enterprise is actually the most critical part. The core is where the information is managed, where the information is archived, and that provides the source for queries and retrieval. And it makes sense to use a vendor-neutral solution for the archive core so that the information can be easily exchanged and we can have multiple vendors making use of these functions and the features. And you want to make sure that you use the right level of the vendor-neutral archive that has all the capabilities as described in the presentation above. Thank you very much.